In this segment, I'm going to cover one very important optimization that occurred in HTTP 1.1, something called the Keep Alive header. HTTP is a basic request response protocol. HTTP 1.0 is very simple. A client wanting to request a document opens a connection. It sends a GET request. The server responds with the status code, such as 200 OK, the document, and closes the connection once the response is complete. If the client wants to request a second document, it must open a second connection. When the web was mostly text with maybe an image or two, this approach worked just fine. People hand-wrote their web pages, putting in all of the formatting. Recall our results from analyzing HTTP 1.0. Loading a single page with these parameters takes 230 milliseconds, and loading a page with 2 images takes over twice as long. A lot of this time is spent opening connections, and if we could request more documents at once, it could be much faster. So the approach HTTP 1.0 uses can be really wasteful. Clients spend a lot of time opening connections. Furthermore, the TCP congestion window doesn't get a chance to grow since each connection has a new window. HTTP 1.1 solved this problem by adding a few headers to requests and responses. A request can include a connection header, which tells the server whether it would like the connection to be kept open after the response or closed. The server can do whatever it wants, but the client can give it a hint. For example, if you're requesting a basic text file, there's no reason to keep the connection open, as the text file won't reference other things to load. A response includes a connection header, which tells the client what the server decided to do. If it decided to keep alive the connection, then the keep alive header tells the client for how long. Now, the client can send further requests on the same connection. It can also open more connections if it wants, but it doesn't have to. So it turns out this is a big deal. Let's consider a more realistic case than before, where the packetization delay is only 1 millisecond and the page loads 11 images. Now, browsers today usually have more than 2 open connections, but they also load more than 11 resources on a typical page, so we'll just keep these numbers small for simplicity. We're going to use the same analysis we used when looking at HTTP 1.0 in the HTTP 1.0 video. The slow starts window is big enough that we'll never hit congestion control. For HTTP 1.0, this will take 1,421 milliseconds. There are 7 rounds. In the first round, we request a page. This takes 203 milliseconds. In the next 6 rounds, we request 2 images each, except for the last round where we request only 1 image. Each round takes 203 milliseconds. So the total time is 203 milliseconds plus 1,218 milliseconds for 1.421 seconds. Now, for HTTP 1.1, this will take only 326 milliseconds. We set up the connection, that takes 100 milliseconds. Requesting the page takes another 103 milliseconds. Requesting the 11 images, though, takes only 123 milliseconds. That's 51 milliseconds for the first request and 72 milliseconds for the 11 responses. 50 milliseconds of latency plus 22 milliseconds of packetization delay. So HTTP 1.1 is over 4 times faster because we can send these requests back to back in a single connection and don't have to open new connections. HTTP 1.1 has been around for a while, since 1997 or so. Very recently, Google has developed a new protocol called Speedy that improves on HTTP. It does things like allow request pipelining. So one issue HTTP sometimes run into is that the order in which a client requests resources is the same that the server responds. So this can be a problem if some resources require a lot of processing. Say you have a dynamically generated web page through something like Ruby on Rails or Django. Your database is overloaded, and so it's going to take a while to generate the page. But most of the resources are just images that can be sent quickly. If the client requests the slow page first, it won't receive any of the images until it receives the page. It would be nice if the server could respond in a different order and say start sending the images while the page is being generated. Speedy also removes redundant headers. Open up Wireshark and look at some HTTP requests and responses. Very often, there's a lot of redundant information in each response and request. If you could just set some parameters such as the browser type for the duration of a session, rather than send it each time, that would speed things up a lot. So Speedy has been in use for a little while, and it's becoming the basis of HTTP 2.0. In a few years, I suspect most sites will be using HTTP 2.0 because of the speed benefits it'll bring, especially for mobile devices.